Hi guys, it's Mrs. Milson, and welcome to my first of many videos that have to do with probability, okay? First thing we're going to do is simulation. Okay, but before we talk about simulation, let's talk about probability. Let's define probability. Probability is simply the proportion of times an event occurs in a very large series of repetitions, okay? Now, why do we have to do a very large series of repetitions? Okay, because events that seem random and unpredictable in the short run often show a pattern or predictability in the long run. So that's why we need to look at large samples, okay, large numbers of trials. Okay, so that pattern, that predictability will start to show up. Okay, so we quantify that proportion as a number between 0 and 1. Okay, so a probability of 0 means the event will not occur. Okay, something has a probability of 0, it will not occur. Something has a probability of 1, it will occur. Okay, if there's a probability of 0.5, maybe it might occur, it might not occur. I wouldn't be surprised either way. Okay, probability of 0.75, it's more likely going to occur, but if it didn't occur, there's still a 25% chance it's not going to occur. So I wouldn't be terribly surprised. I'd be a little surprised. Okay. Probability of 0.99. Okay. That's pretty much going to occur. If the event doesn't occur, I will be extremely surprised. Okay. We can go on the other end. If we have a probability of, say, 0.1, okay, so a 10% chance something's going to occur. It's probably not going to occur. I would be a little surprised if it occurred, but not knock my socks off surprised, okay? Now, say there was a probability of 0.01 that an event would occur. It's not going to occur. If it does happen, I would be extremely surprised, okay? So we have these numbers on the extreme ends that if the opposite happens, I am very, very surprised. Everywhere in between, I'd be a little surprised, sometimes more than other, but not really. Okay. All right. So before we get into all the probability rules and everything else, we're going to do a simulation. Okay. So what a simulation is an imitation, of a chance behavior based on a model that accurately reflects the situation. Okay. So if I was going to model a probability where the events have a 50-50 chance of occurring, I might simulate that by choosing a random number between 1 and 2. If I was going to simulate the behavior of picking a specific card out of a deck, okay, there's 52 cards in a deck, so I'd have to imitate or create an imitation where the probability of each event is 1 out of 52. Okay, so when you simulate probability, the probability has to accurately reflect the situation, okay? Why do we perform simulations? We perform simulations for two reasons. To determine if a specific outcome is possible, okay? So I will simulate flipping a 2 die to see if it's possible to get 3 doubles in a row, okay? And then we also do simulations to estimate the probability of a specific outcome, okay? I don't have access to, I don't want to sit here and roll 2 pairs of die 1,000 times, so I run a simulation model on a computer or a calculator to represent those 1,000 rolls, and then I can come up with an estimated probability of getting 3 doubles in a row, okay? All right, and why does this work? Because of the law of large numbers. After many, many trials of a random process, the estimated probability will converge to the true probability, okay? So I'm going to do a simulation, and we're going to do a large number of trials, probably up to 20. I should probably go more, 100, 200, but, we have time constraint. I'm just using my calculator. Okay, so the easiest, most straightforward simulation I can think of is flipping a coin, okay? So we are going to simulate flipping a coin and estimate the probability of getting a heads. Now, we all know that the probability of getting a heads or a tails when you flip a coin is 0.5 because there's 2 options, heads or tails, okay? But we're gonna do a simulation because I want to show you how the law of large numbers works, how after many trials, our probability will start converging towards that 0.5, okay? Now, when we do simulations and we get to inference later on, but pretty soon, we use a 4-step process called state, plan, do, and conclude, okay? So I've set this up in that 4-step process. So the first thing we state is what we're gonna do. We will estimate the probability of getting a heads when you flip a coin. Okay, now remember, this is a simulation. I'm not actually gonna flip a coin, okay? So how can I simulate flipping a coin? Well, flipping a coin, there's only 2 options, heads or tails, so I have to kind of emulate that 50-50 probability. So I'm gonna use my random int in my calculator, and I'm just gonna choose a random number between 1 and 2. Okay, I'm gonna go down to random int, choose a random number between 1 and 2. Oh, I think I have to put 1 in there. Oop, I need to put my little 1 in there. Okay, so that will be, every time I run this, that will be a single roll or a single flip of my coin. So let's identify what's what. So 1 will equal heads and 2 will equal tails. Okay, so I'm gonna do several flips. I think I've got 20 boxes here. So let's see. Okay, I'm gonna do 20 simulated flips. And then I'm gonna record the number of heads on each flip. And then I'm gonna go back and do the cumulative number of heads, and we'll do the cumulative percent, which will correspond to the probability. And this should start to converge and get closer and closer to 0.5. Okay, so my first simulated flip was tails. So I did not get any heads. Okay, so right now I have 0 heads. So 0 out of 1 is 0%, okay? So right now with my 1 trial, I would estimate the probability of getting a heads to be 0, okay? If I run it again, I get another tails. So now I've got 0 out of 2, and I would still estimate the probability of getting heads from these 2 trials to be 0. Okay, next one is I finally get a heads. So now I've got accumulation of 1, so 1 out of 3. So now I'm going to estimate the probability of getting heads to be 33%, or a probability of 0.33. Okay, so out of my 3 trials, now my probability is starting to get closer to 0.5. Okay, let's do another trial. I'm going to run my trials and just put my number of, every time I get a heads in here, I'm going to mark it, and then we'll do the cumulative. Okay, a couple more. Okay, so now I still have accumulated 1. Now I've got 2, still 2. Now I've got 3. Now I've got 4, 4, 5, still 5. Accumulated 6, 7, 8, 8, 9, 10, 10, and 10. Okay, so now if I go through and fill in all my rest of my chart, so now this is 1 out of 4, which is 0.25. 2 out of 5, yes, I'm putting that in the calculator, 0.4. 2 out of 6, that's 0.33. 3 out of 7 rolls, don't know what 3/7 is, 0.43. 4 out of 8, 0.5. 4 out of 9, 0.44. 5 out of 10, 0.5. 5 out of 11, 0.45. 5 out of 12, 0.42. 6 out of 13, 0.46. 7 out of 14, I know that's 0.5. 8 out of 15, that's 0.53. 8 out of 16, that's 0.5. 9 out of 17, 0.53. 10 out of 18, 0.56. 10 out of 19, 0.53. And then 10 out of 20 equals 0.5. Oops, I'll put my decimal right there. Okay, so you'll notice they're all bouncing around. If we graph this, where's my paper with my graph? Okay, if we graph this, so for every flip, every simulated flip, I'm going to graph the cumulative probability, the cumulative percent. So I started at 0, 0, 33 roughly, 0.25, point, wait, I did 0.25, 5 and 0.4, 6 and 0.33, 7.43, 8 and 0.5, 9 and 0.44, 10 and 0.5, 11.45, 12.42, 13.46, 14.5, 15.53, down to 0.5, 5.3 again, up to 5.6, down to 5.3, and down to 5. So you'll notice that the graph it starts to concentrate along this true probability, or starts to converge onto the true, towards the true probability, okay? So this is 0.5. This is the true probability of getting a heads, okay, when you flip a coin. So if I continued past 20, because 20 is many trials, but it's not many, many, many trials. I should really do like 200, okay? What will happen is this probability will just start bouncing above and below 0.5, and it'll get to the point where it'll just end up being 0.5, okay, after many, many trials. So that's how a simulation works, okay? So let's write our conclusion. So from our, or we're just gonna write, we estimate the probability of getting, that's a G, heads when you flip a coin to be 0.5. And you know what? Our estimate is pretty darn close. As a matter of fact, it is exactly what the true probability would be, okay? So that's how a simulation works. We don't usually get it right on the, hit the nail right on the head, but this one was a good example, okay? But hopefully this demonstrates just how simulations work. And we've done others in class, but I thought for the general video, flipping a coin would be the easiest one because everybody knows that probability. Okay, all right, I hope this was helpful, and I will see you for the next video. Bye-bye.